Hello everyone. When it comes to a digital audio playback system, we've previously talked about its three main parts: music storage or music server, the bridge which serves as the output end, and the playback controller. But today, I want to explain how we should think about optimizing these three parts. This is important because many people don't realize where optimization truly matters most. Let me emphasize this. The playback controller is the true core of the system. But this doesn't mean your remote controller, not Bubble Up EMP, not Roon Remote, those are just remote control apps. They don't process any data, and the music data stream doesn't pass through them at all. They're only issuing commands. The real playback controller is the part of the system that handles the actual flow of music data. It reads the files, processes them, and sends them to the client or output device. That is the true player and is the part that needs to be taken most seriously. If you have a limited budget, this is where you need to invest first. Even if you're not using a network bridge, even if you're just outputting through local ASIO or system drivers, the playback controller is what determines most of your final sound. Its buffering strategy, filtering, and latency behavior of that directly affects performance. From a system design perspective, this is always the #1 priority. Second comes the output section, or what we call the bridge. If you're using an all-in-one device, then this would be the system's internal audio driver. Take Android for example. It's absolutely essential to enable exclusive audio output, or you'll compromise quality. The reason some people separate the bridge into a standalone device is because today's USB interfaces typically come with no buffering. Most USB interfaces on the market now don't buffer at all. For instance, Exmos chips buffer about 250 microseconds, which is only around 2 audio frames. That's incredibly small compared to the millisecond level buffering found in most playback software. The gap between milliseconds and microseconds is huge, multiple times greater. Because of this gap, if your playback controller gets busy or the system is under load, USB output can become unstable, and that instability can directly affect the quality of your IR-Quad-S signal. However, if you use a standalone bridge, it can buffer the data stream and then slowly and steadily deliver it to the DAC. It might buffer for hundreds of milliseconds without issue because it's simple, has one job, and doesn't need to multitask. It just receives the data, buffers it, and transmits it smoothly. And because of this, it can output a much more stable, jitter-free signal. That's why a good bridge can noticeably improve overall sound quality. Now we come to the third component: music storage and music servers. In the hi-fi world, storage affects the playback controller, not the bridge. This is because the data flows from storage to the controller first, and only then to the bridge. So in a way, storage indirectly affects sound quality by influencing how stable the controller can operate. To build a good music server or storage system, first and foremost, it must be low noise and high signal integrity. That's a fundamental hi-fi requirement. You don't want noisy consumer drives ruining your sound. For example, if you plug a cheap, noisy hard drive into something like the D1X, your sound quality drops instantly. That's why we recommend pairing NAS devices with hi-fi network switches. Or if you're using USB drives, use a dedicated hi-fi drive like DiskOne, which is deeply optimized. But low noise and high signal quality aren't enough. Your storage must also respond quickly and consistently. If your hard drive or NAS is slow to responsive, sometimes it loads fast, sometimes it lags, then your controller suffers. And if the controller is affected, so is the sound. Music playback is a continuous process that demands steady, uninterrupted access to data. When the system is forced to wait for storage, it creates fluctuations in power usage, which leads to electrical noise. That's where instability and distortion come from. Think of it like drawing water from a tap. If the flow is steady, everything runs smoothly. But if the flow fluctuates, everything downstream suffers. Stable storage means stable controller behavior, which leads to stable noise levels, stable power draw, and ultimately better sound. So even if you're using a simple all-in-one unit, you still need to pay attention to what kind of storage you connect to it. The hard drive must be quiet, precise, and most importantly stable in its read performance. If it hesitates, if it sometimes freezes or slows down, it's not suitable for hi-fi use. If you're streaming from a NAS, your network switch also needs to be evaluated. Open a folder if it lags. That NAS is not ideal for hi-fi. Even simple setups need this kind of consideration. And if you've built a full separate system with individual player, bridge, and storage roles, then optimizing each part becomes even more important. Finally, I want to add this. If you aim to bring all three parts, controller, bridge, and storage up to high-end level, it's incredibly difficult. There is no perfect all-in-one solution yet. Even our D1X, which is built as a reference-grade device, only achieves that level because we've optimized every last detail level interface, every voltage rail from 1V USB and network pass all the way up. Do you expect the NAS to be optimized like that? Most hi-fi NAS solutions haven't even reached this level, let alone high-end. So I really encourage you to pay attention to the details of your source system. We'll be sharing more in the future on how interface level interference happens and how to deal with it. Thanks for watching, and I appreciate your time. See you next time.